So, in the second topic of the JEE ADVANCE GOC lecture, I said we're going to talk about hyperconjugation. So, hyperconjugation is also called no bond resonance or Baker-Nathan effect or sigma p conjugation. Now, this is something you should keep in mind as it has come before in the JEE ADVANCE PYQ is sigma and p empty conjugation takes place for carbocation. Sigma pi star. What is pi star? We studied in chemical bonding. It's the anti-bonding, right? Empty conjugation. This one is for alkene. Now for free radical also one is there, which is sigma p. This time it's half filled conjugation for free radical. Okay. Now in hyperconjugation we have to look into the sp3 alpha carbon. So what is alpha carbon? Like, let's take for different cases. CH3 CH2 C plus H2. So this is alpha. You get the idea, like the one joined to the carbocation. This is the alpha carbon. And let's take for double bond CH2. This is the alpha. For free radical, same thing as this one, so it's alpha here, right? Okay, it has to be sp3 also, don't forget that, to have an alpha hydrogen, right? Now let's look at hyperconjugation in carbocation. Carbocations. So first of all, let's have here C. I bet all of you know how to draw this diagram. Dash H CH2 plus, then you have an orbital over here. It's free orbital. So in hyperconjugation, obviously this is an alpha H, this is an alpha H, this is an alpha H. This goes here and it goes here. So you'll be forming what? Let's say this is hydrogen A. C, this is hydrogen B, let's say. So hydrogen C is going to form a carbocation on the, not carbocation, going to form an H plus. Sorry. And it will form a CH2 over here. This is no bond which is forming over here during hyperconjugation, so it's called no bond resonance. See, over here there is a delocalization of the sigma electron, which is also obviously hyperconjugation. Now if we do the same, we'll also have the HA going, the HB going, right? So you can form a hybrid, resonance hybrid, which is like this C H A del plus H C del plus, partial bubble bond character over here, right? We know hyperconjugation C plus is called as sigma p empty conjugation also. And this is the main thing which you need for solving question. More the number of alpha hydrogens, more stability. For the carbocation, right? And also one important point is number of alpha hydrogens is equal to number of hyper-conjugation structures they might ask for this how many hyper-conjugations. So you just check number of alpha hydrogens. So let us take an example on how to find an alpha hydrogen. Let's take this for example, CH3 plus here. So if we look into this, you'll have 3 alpha hydrogens from here, 2 alpha hydrogens from here, 2 alpha hydrogens from here. So you have 7 alpha hydrogens. So you have 7 structures, right? How would I check that this has 7? This is an alpha carbon, this is an alpha carbon, this is an alpha carbon, sorry, and this is an alpha carbon, right? sp3, yeah, it's sp3. Now I'd like to take one more example, which is CH3, CH2 plus, and CD3, CH2 plus, right? The answer for this is this. It is as CH, CD. This is the bond energy thing. So the extent of hyperconjugation will be CH more than CD. Okay. I guess that's enough for this. Now let's go to for hyperconjugation in alpha radicals. In free radicals, now again there'll be an H going, but this time the H will get free radical instead of the plus charge. It's the same thing. So, and again, yeah, more number of alpha hydrogens, more stability, right? Let me give you an example. So how you can check this. So let's take this. Let's take this. Let's take this. Let's say free radical is here. A free radical is here. Free radical is here. So over here, now we check. This is an alpha carbon. This is an alpha carbon. This is an alpha carbon. This is here. This is here. And this is not an alpha carbon. This is beta carbon. This is alpha carbon. Now if we check, this has 3, 6, 9 alpha hydrogens. This has 6 alpha hydrogens. This has 2 alpha hydrogens. So the more stable, right? Now hyperconjugation in alkene takes place between sigma and pi star. This is important. Now how this takes place? Let me do it. So you have a C, you have this edge, you have C edge, CH2, right? See, this lies in the plane like this. On this edge, let's say it goes like this. This is the pi star orbital. This is the pi star orbital. Honestly, this is not required, but just telling it just for the sake of it. So after that, it'll just be forming this CH2 minus, it'll be forming a 9 HA plus, right? So again, more number of alpha hydrogens, which I've told how to find the alpha carbon for double bonds, the same way you do it. Now let's take an example. Let's take a simple example first. Here, then you have here, This you have here. Right. Now, this is an alpha carbon. 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 For this is an alpha carbon. So this is 3, 6, 7, 8, 9, 10. 10 alpha hydrogens. This has what? 1, 2. So this has 3 alpha hydrogens. So obviously this. Now, this is an important example. Here we have. Oh, sorry. You have this, and you have this. This is called isobutene. This is called cis-butene, cis-2-butene, and this is called trans-2-butene. Okay. Now if you check, alpha hydrogen is same. But if you convert into its corresponding anion, you'll get this. Let me draw it. CH2. Like how we did in that structure there. You just have to remember how it came. Don't need to think about the pi star thing. That might just confuse you. Then this CH2, CH3 minus CH3 minus CH2 gone. Yeah. So this is a 1 degree anion, this is a 2 degree anion, this is a 3 degree anion. Same we decide by anion. So then, first of all, 1 degree anion is obviously more stable than 2 degree anion. So trans is more than cis, we can say. So we get this order, which is this, this, this. That's it. Okay, so some things you should know is some applications of hyperconjugation. First is heat of combustion. Number of carbon atoms, and this is also inversely proportional to stability. Nothing much I can explain here, you just need to remember this. Heat of hydrogenation, heat 1 by stability. So I guess this was enough for hyperconjugation. I hope it was helpful, and thank you for watching. In next we're going to cover resonance. Okay, thank you.